Hi everyone. So today's problem of the day is create binary tree from descriptions. So what is given in description? You are given a 2D integer array description. Your description I equals to parent I, comma child I, comma is left I. Indicates that parent I is the parent of child I in a binary tree of unique values. Furthermore, if left I equals to 1, then child is the left child of parent. If left I equals to 0, child is the right child of parent. Construct the binary tree described by description and return its root. The test cases will be generated such that the binary tree is valid. So what will be basically given in this question is like we will be giving a description vector, and where description I will be representing in such a way that it will be parent, comma child, comma is left. What it will show like this will PA will be the parent, CH will be the child, and is left if it is value is 1, then this child is the left child of this parent, and if this is left equals to 0, then this child is the right child of this parent. So if we will see the and we need to return the root of the binary tree, and we need to construct the binary tree. So we will see the example, and there will be unique binary tree only, and it is a valid, always a valid binary tree. It will be given in the description. So if we will see more in the example, that we can see 20, 15 and 1. So 20 is the parent, 15 is the child, and 1 is showing that it is the left side. So 20 is a parent, 15 is a child, and is a left child. Then 20, 17 and 0. So 20 is the parent, 17 is the child, and 17 is the right child. Then 15, 21. 15 is the parent, 20 is a child, and this is the left side. So it will be somewhere here. Then 50, 80 and 0. So 50 is the parent, 80 is the child, and it is the right child. Then 80 is the parent, 19 is the child, and this is the left. And that's it. So this we have construct the tree. If we will see for the second example given in the question is 1 to 1. So 1 is the parent, 2 is the child, and this is the left child, and 2 is the parent, 3 is the child, and this is the right child. 2 is the parent, 3 is the child, and this is the right child. And 3 is the parent, 4 is the child, and this is the left child. So somewhere this will be the binary tree possible using this description vector. So if we will talk about the solution, like how we can solve this problem. So before thinking about the solution, we need to see which data structure we need to use to solve this problem. Like we need to construct a binary tree, and we will be giving one description vector. So if you will see in binary tree, we will be using node value. So node value which contains one integer. So and we have given only integer, and we have not and it is also given in the question that there are unique integers. Like if one is there in the tree here, then one can't be somewhere here in the bottom of the tree. It will be unique only one time that integer is present. So we need to map the integer with the node, and we need to create the node, and we need to map a particular unique integer with the node. So this is the one thing that we need to do. Then how we can suppose we have mapped the integer with the node, and with the help of this description we can construct a binary tree also. But how we can find that this is a like which is the root node? To find the root node, we need to we need to store somewhere the child. We can store somewhere while traversing description. We can store somewhere our child, and we can again traverse this description, and we can see if that value, this first value of every vector, if that value is not there in the child, that means that is the parent node, and we can directly return that node at the end. So these are the two things. So you can guess in the comment section that which data structure we can use. Then I will let you which data structure will be more fit into this. So I hope you can pause the video and you can put in the description like which data structure we can use, like which will be the most appropriate data structure for this solution. So I will tell you. So we need to store a particular integer ki corresponding. We need to store a node value. So we can use the map in this, because map where we can create a map of int comma try node, where corresponding to one integer there will be a one node. So again, if we will get some integer, like we got this 2, we created the node, then again we got the 2 in the other vector, so we can directly, with the help of that integer, we can directly take this node value. So we can create node of int comma tree node to store our int node pair. Then we will use to store the child, again we will use the map. We will store int comma int. This will store the child integer, and this will store how many times the child integer is occurring. So to understand it better, we can directly see the code, because while seeing the code, you will understand it better. Like the main solution I have already explained you, like how you can approach this problem. First, you need to before jumping directly into the solution, we need to find which data structure will be more appropriate. Then what if the data structure is map, then what kind of map can be used? Int comma node or int comma int? For what purpose? What can be used? Then we can jump to the solution. So if I will see the solution, what I have done, I initialize this integer, which is the size of this description vector. Then this map I have used to store the integer with the corresponding node value, and this map child I used to store my child value, because at the end I need to find which is my root value to return the root. Then I started from 0 index till n minus 1 index, and this di comma 0 will be the parent, di comma 1 will be the child, and int is left equals to di2. Then we will initially declare this parent, and then we will try to search that into our map. If that integer is already present, this p is already present, then we can directly assign this parent equals to the if it equals to mp dot end, that means it is not, we reached till the end and we did not find that integer. That means we need to create that node. Then parent equals to new try node p, and we can store that integer corresponding to that parent in the map. And if that is already there in the map, then we can directly assign that value from the map mpp. In the same thing we need to do for the child, and we can assign the same thing into the child. And at the and after that we need to see if this is left equals to is 1. That means it is a left child. If it is a left child, and what we can do, we can use this parent left equals to child, because this parent and child are the node now. So we can directly do this left equals to child and parent right equals to child. And at the end, we can store our child into this mpch map, because we are in this vector, we are storing all our child because at the end we need to find which is the parent. Then tree node is the root. This is I am doing to find my parent. Then I can do this if condition, that if my this di comma 0, which is the parent, which is showing the parent, if that is there in my child map, then don't need to do anything. But if it equals to 0, that means we reach the end and we are not able to find that parent. That means this is my parent. Then I can assign this root equals to this value, and I can break the loop. And at the end, I can return the root. So this is the solution. I hope you are able to understand the solution, and let me know what will be the time complexity according to you. Time complexity and the space complexity according to you. If you will see this for loop or this vector, then you can be able to find the time and space complexity. If you are able to find it, then you can put that in the comment section, and you can pause the video and put that in the comment section, and then I will tell you. So the time complexity, since we have used only one for loop here and one for loop at the down, so time complexity will be big of 2 into n. 2 is the constant, so it will be big of n only. And space complexity, since we have used two unordered maps, so space complexity will be big of 2 into n again. And 2 is the constant, so space complexity will be big of n. So yeah, thank you.